problem twice, but here we go, the third time's the charm. We're going to do page 8, which is review 2, and we're going to get letter D. D, 5D. The very last problem. All right, so here we go. We did that one? Yeah. All right, let's do one like it maybe that we haven't done. So let me look on the other sheets. All right, I don't see one on the that we haven't done yet because we already did page 6. So I'm going to just make one up. Okay, so here's the deal. We want to minimize the area of this, and here are the constraints. We're going to put a picture in here, and the size of the picture is 132 square inches. And we want to kind of fancy frame this picture, so we're going to have 2 inches on this side, 2 inches on this side, and 1.8 inches up here and 1.8 inches down here. Okay? And we want to minimize the area. So, what do? Area. How do we find area of a rectangle? Length times width. So, in order to do this, we need to find this distance and this distance. This is the width, this is the length, right? Okay, now let's look at this. If we go side to side, we know we got 2 inches here and 2 inches here. So we know we have 4 plus whatever this is, right? So we'll call that x. So the width of the paper is 2 plus x plus 2. Now what about the length of the paper? Well, I got 1.8 and 1.8, so I know for sure I've got 3.6, plus whatever this is right here. What's this dimension? If the area is 132, and that's x, what's this dimension? 132 over x. So I've got a 1.8, a 132 over x, and a 1.8, so 3.6 plus 132 over x. Now, that's my dimensions, or those are my dimensions. So my area will be those two things, those two things times each other. Now, this will be on the calculator part of the test. So you will have your calculator.
Please pause this interruption. At this time, can I please have all of the cheerleaders dismissed to the Welch Activity Center? At this time, we need the cheerleaders only to be dismissed to the Welch Activity Center. Thank you.
All right, so I'm going to graph this on my calculator, and I'm just going to type in the equation just like it is. Not going to multiply it out because that would be yucky. But before I press graph, I'm going to adjust my window. All right, now we had issues with this before because you weren't using an appropriate window. I'm not saying a wrong window because this thing has, its domain is everything except 0. So you can get a huge graph for this. But talking about appropriate for this problem, what do we know about x? It has to be positive, doesn't it? So x min is going to be 0. I have no idea what x max is, but y min has to be 0 too. Right? Because y is the area. So my two minimums are zeros. I have no idea what my maximums are, so I'm going to press graph. I don't see anything. What does that mean? I need it bigger. That's okay. I'm not panicked. I'm going to make it a lot bigger and see what happens. There, I finally got something, and I didn't panic. It took me a total of 15 seconds. Not an issue. I stayed And now I have a shape that looks like this. I went all the way up to 1,000 here, and I went out to 100 here. I was just randomly guessing numbers until I saw a picture. Right? Now, what do I want to know? There, I got my picture. What do I want to know? Minimum. Second calc. Pick minimum. Set my bounds. And I will find my minimum point. Now, because I kind of made this problem up on the spur of the moment, and I didn't even really write a problem, I'm not sure what the answer is. So let's talk about the possibilities. What?
Are you missing an X in the equation up there?
Am I missing an X in the equation? I hope not.
Is that mine looks different? No.
I'm not missing an X. My equation is right.
Okay.
Did you put an extra X in?
No.
Does your equation look just like mine?
Yes.
Did you use the same window I did? 0 to 100 and 0 to 1,000?
Oh.
233.6. Now, without having, does anybody confirm that?
Yeah.
All right, without having the actual question, I can't answer, so let me give you a couple possibilities. One possible question might be, what is the minimum area of the paper? So if that were the question, what is the minimum area of the paper? Then what would be the answer? 233.6 square inches or whatever, right? If it said, what are the dimensions of the picture? Remember I said we were going to frame a picture and this was the original picture. If I said, what are the dimensions of the original picture? Then it would be 12.11 and whatever 132 divided by 12.11 is. These would be the dimensions, right? And that would key on your X value. All right, good. Who can think of another problem? Anywhere in the packet, any kind of problem at all. You've already done it, I'll make up another one.
On page 8, you do number 1.
What?
You do number 1.
On this same page?
Yeah.
Page 7, number 1?
Letter A.
Okay, page 7 doesn't have a 1 in it. Are you on
8.
You're on page 8? 8, 1A. We're solving a quadratic inequality. What is our strategy with every inequality? Unless we're doing it on our calculator, which we're not. This is a no calculator problem.
So you set it equal.
You gotta get a 0. So we get a 0. Alright, then what do? We figure out a way to factor it. And some of them have been a lot bigger than this, or we've had to do the whole PRR thing. Obviously this one's simple, so we don't need to do that. But it is possible that you'll need to do the PRR thing to get it factored. Once you get it factored, what do? You draw your number line. And you put 2 dots on your number line, right? They would be open dots in this case because of the symbol. And the dots will be where?
0 and 8.
0 and 8. We normally use 0 as our test point. You can't in this problem. Emily, you okay, honey?
Yeah, I just looked it up.
You want to go to nurse?
Yeah, I can.
You're absolutely fine. Take your stuff. Because then if you feel better, you can go this summer. But we're going to go in 24 minutes. You probably just need to lay down.
Okay.
I'm going to email her and let her know you're coming. So. Here you go. Alright, I can't use 0, so I gotta use some other number. 1, I'm happy to use 1. 1's right here. So I'm checking this space right here. So I'm gonna put in 1, and I have 1 times -7. If I put in 1, that's what I have. Is that what I want?
No.
No. So I don't shade where 1 is, I shade where 1 isn't. So my answer is everything from -infinity to 0, or from 8 to infinity. Agreed?
Can we leave the number line, or do we actually have to put it in?
You actually have to put an answer. Yep, yep. Now, when I'm grading homework and I'm grading your test, I'll be looking for the number line because that's how we've been doing it. But the answer is what we actually need to come up with that, some X values. All right, who else? Page or problem number, here we go. Or it can be a book problem, I don't care. Anything we need to review. Jade.
Can you just do the next one, 1B?
The one right under that is exactly the same kind of problem as this one, only it is bigger, which means probably factoring it is going to be more of a hassle. So as I copy it down, I'm going to get a 0 because that's what I always want to do, get a 0. And I can see it doesn't group. So this is an example of one where I'm going to have to do the PRR thing. Anyways, oh, 1 works. I can see right off the bat 1 works. So I'm going to divide it out. Now, you might be sitting there thinking, gosh, Miss Ford, you did that fast. Well, remember, I'm old and I do this for a living. You're going to pick a number, you're going to plug it in, and it's either going to give you 0 or it's not. If it doesn't, you pick another one, and I promise it's not going to, you're not going to have to pick very many. You'll get one relatively soon, and then you divide it out. Make sure after you find one, you divide it out. Okay, then what? Factor. So what? Let me write down what's left. X squared plus 6x plus 8, which is x plus 2 and x plus 4. I wish I had a nickel for every time a kid forgot the x minus 1. Because when you go to the number line, you need 3 dots. There are 3 factors. These 2 you got from literally factoring. That one we guessed, right? He has to be included. So your dots, you're going to have 3 of them. They're going to be at -4, -2, and 1. They'll all be closed in because the problem is or equal to. And I can use 0 this time. It is out here. Oh, excuse me, it's in here. Pay attention. It's right here, right? So I'm picking 0. And 0 would give me -1 times 2 times 4, which is what I want or not? Yes, so that works, doesn't, does. So my answer is everything from -infinity to -4, or everything from -2 to 1.
How'd you know it didn't work between -4 and -2?
It turns out, if we did like 50,000 of these, that it always alternates. See, one sign here is going to change as you move from interval to interval. So if this one makes it negative, this one's automatically going to make it positive, and this one's going to make it negative again. The only time that doesn't work is if we would have factored and had like a squared in there, then all bets are off, and you would check each space. But if you don't have anything funky going on, it's always going to alternate. Cassie?
If it doesn't, like, factor, you do quadratic.
You do. Now, I won't do that to you in an inequality situation. Your inequality will be factorable. Now, I might do that if it's a solved problem, where it's like just x equals, but not with these, because it's too hard to find them on the number line.
I just have a question about those problems. So, when do you, I remember you saying something about you can't shade them. You know what I mean? When
You mean
have a
color in the
certain-
dots?
Yeah, when you have a certain something.
Okay, when do I worry about that?
Denominator.
That's
When
what
I
I'm
have a
asking.
denominator. Because denominators can't equal 0, right?
So the next
Is it ever going to be an issue in a problem like this? No, because there's no denominator. Now, put it over something, then I'd have a dot at -5, but that dot would be open because it's in the denominator, and they can never equal 0. You cannot put in a -5 in that problem. On that same page, find the end behavior asymptote. Now, keep in mind, end behavior asymptotes can be horizontal. End behavior asymptotes, this big family of asymptotes, of kinds of asymptotes, and they can be horizontal. Now, when I look at number 3, it is not horizontal. How do I know? Powers aren't the same. And actually, if that problem were upside down, this one would have a horizontal asymptote. Even though the powers aren't the same, there'd be a horizontal asymptote here. It would be at 0, 0, 0, right? When the power on the bottom is bigger, your asymptote's at 0, y equals 0. The only time it's not horizontal is when the power on top is bigger, and that's the situation we have. So, what do we do when the power on top is bigger? We actually divide it. This is a division problem. We just do the division. Simply do the division. Now, what part of that, or where do I get my asymptote from that? Remember, this guy's the remainder, right? And he doesn't count. All that counts is what's left. This was x squared, so this is x. So y equals 2x plus 2. So my end behavior asymptote is a line with a slope of 2 and a y-intercept of 2. Right? Okay, who else? What else? When you sit there, it makes me think you know everything, which would make me very happy, but Cassie?
On C, 1C.
1C?
When you put everything together, you get negative x. You need to make that x.
No. Let's look at that. So this is an inequality, so we're going to get 0. So we're going to subtract 2. That's how we would get 0. We subtract 2, right? Now.
Please pardon this interruption. At this time, could we have members of the band dismissed to go to the Welch Activity Center? At this time, we need members of the band to be dismissed to prepare for the assembly. Thank you.
Okay. Now, back in the old days, I mean the really old days when Father Kelly was principal, he'd just decide, like, in the middle of the period, he'd just decide, we're going to have a pep rally today. So he'd come over the PA and say, in 10 minutes, we're all going to the gym for a pep rally. And, okay. That was before we had all these schedules that we had to follow. All right, what do we do now? We got my 0. What happens now? Get a common denominator. Oh, I'll just do it here. So I'm going to multiply that one by x plus 4 over x plus 4. So my common denominator is x plus 4. I've got my x minus 3. Watch it now. Minus 2x minus 8. Because I'm distributing that negative 2, that subtraction. So this is what Cassie was talking about. When I just collect like terms, negative x minus 11. Okay? Jack, math makes me happy too, but I don't chuckle all period. What are you doing over there? All right, what do I do? What do I do? I go to my number line, and I put 2 dots on it. And where do the 2 dots go? Well, one of them's at negative 4. And if all that confuses you, which is, I mean, there's a lot of stuff going on there, just solve it. Set it equal to 0 and solve it. And it looks like the other one's going to be at negative 11. Now, is anything there colored in? I see it all equal to here.
Negative 11.
The negative 11 is colored in, but the denominator dot can't be colored because x can't equal negative 4. Can I try 0 this time?
Yes.
Yes. So when I put 0 in, I get negative 11 over 4. That's what I get when I put in 0. Is that what I wanted? Nope. So that didn't work, and this one did, and that one doesn't. So my answer is negative 11 to negative 4. Brenton?
For 1D, is that an equal sign, right?
Yep, that's an equal sign.
Okay. all the denominators.
So what I would do in 1D, and again, you do not have to do it the way I do it, but the way that we did them when we actually went through this material was, if it's an equals, we got rid of the denominator.
Oh, dude.
So if it's an equals, you cannot do this in an inequality. But if it's an equals, I'm going to multiply everything by the common denominator, which is x plus 1, x minus 2. And that's everything, including the 4. Everything that's multiplied by x plus 1, x minus 2. Everything. Now this is the way I do it. You don't have to do it this way. At some point though, you got to get rid of that denominator. So I'm just going to do it right from the beginning. Okay, so we got some canceling. So foiling, that's a FOIL. This is just a distribute. Okay, that's a foiling. And all that's gone, so it's just plus 3. Alright, so collecting like terms, I've got 4x squared minus x plus 4. Hopefully I added everything there, right? Equal to 4x squared minus 4x minus 8 plus 3 minus 5. Everybody still with me? Now, I thought this was going to be quadratic, but it's not because these disappear, right? So I've just got 3x equal to negative 9, so x equals negative 3. Now, this is the kind that you have to be on the lookout for extraneous roots. What are the excluded values here? The excluded values would be negative 1 and positive 2. I didn't get those, so I'm good. But if this would have come out to be like x equals 2, you would have had to throw it out. You can't have negative 1 or 2 as answers to this problem. They're called excluded values.
Mrs. Ford?
Yep.
If you had to throw it out, what would you do after that?
You just throw it out. So you don't have an answer. Yeah.
Can you say what you said about excluded values?
There, whatever makes the denominator 0. So in this problem, I don't have to worry about it because I didn't get negative 1 or 2 as answers. But sometimes when you solve these, you get an excluded value as an answer, and you have to, it's extraneous then, you throw it out. Sometimes, Burkhart, we get 2 answers when we solve these. Like if these didn't cancel out, I get 2 answers. So one of them might be 2.
Yeah.
Well, then I would throw that one out and keep that one. All right, who else? We got time for a couple more. Here we go. Dylan?
Can we do any of number 4? So
4A. So what are the excluded values?
yeah.
Excluded, I just got done telling you, what are excluded values?
What makes it 0?
Whatever makes the denominator 0. So what would make x squared plus 4x equal to 0?
Negative.
Well, what would I do? I would factor that. What would make that 0? 0 and negative 4. So your excluded values would be 0 and negative 4. Cassie?
Can you do number 2 or
2. We have to graph this thing ultimately, but before we do that, we'll find all of the pertinent information, asymptotes, intercepts, and holes. So what am I going to do first? Even as I'm copying down the problem, what am I going to do with it? I'm going to factor it. Always, always, always factor first.
Number 2.
So my numerator is x plus 5, x minus 2, with that 3 stuck in there. Alrighty? Now what do we notice?
Whole.
We're gonna have a hole because we can cancel. So I'm gonna rewrite my problem. I'm not going to be lazy. I'm gonna rewrite my problem and I'm gonna put a box around it. That reminds me, that's where I'm looking now. Everything I do is focused right here. Where will that hole be? Let's go ahead and get that plotted before we forget it. The hole is gonna happen where X is what? 2. And how do I find the Y?
Plug it into the new one.
Plug 2 in. And when I plug 2 in, on the top I would get 21 and on the bottom I get 4. 21 fourths. Okay, so 21 fourths. 1, 2, 3, 4, 5, and a fourth. So it's right here. 221 fourths. Opened up. Right now, look right here. What else can you tell me?
The X.
What?
Or your vertical asymptote.
Vertical asymptote would be where? X equals -2. And if I have to write that down in an answer blank, I'm going to write X equals -2. That makes the denominator 0. All right, what else do I have?
You have a horizontal.
I have a horizontal asymptote because don't my powers match? I got 3x over x, so my horizontal asymptote is at y equals 3. You can even look at the original if you want, 3x squared over 1x squared. All right, what about my intercepts?
Where do you place the
Where's my y-intercept?
So you plug in 0.
I plug in 0 for x, and what do I get? 15 halves. So there's, let's see, 3, 4, 5, 6, 7, 8. There's 15 halves right there. All right, where's my y or my x-intercept?
Plug in 0 for Y.
So if you plug in 0 for y, you lose the denominator. Your x-intercept's at -5. Now that is all of the stuff you had to find.
Now you gotta grab it.
So now we gotta graph it. Keeping in mind that you got these asymptotes here guiding everything. So what's happening out here? Look, you got 2 points out here. What's happening?
Going down.
This, right? How about over here? You got a point over here. Like that? If you don't get it, then plot some points. Plot some points. Set up a T-chart, plot some points. Now I'm going to ask you a few questions that aren't on the sheet. So see how many of these you can answer. Alright, let's see how many of these we can answer. Take a minute, but we're not going to do it out loud just yet. I want you to take a minute and see how many of them you can answer on the, based on this picture. How many of those questions you can answer.
Oh, wait, fine. Okay. Miss Gordon,
Yep.
how do you say something closer to y equals 3? Do you put y equals 3 or you put 3? So
Okay, so here's the deal for this assembly. We're gonna leave, you're gonna go from here, but leave your stuff and we'll come back and get it, okay? Alright, not yet though, not yet, we gotta answer these questions first. We're not going anywhere until we answer these questions. And you sit with your, like, seniors sit together and juniors sit together like that. We don't sit as a group. As much as I'd like to. Alright, so who's got an answer to any of these? We're not going anywhere, do not pack up, you'll just make me mad.
the first one's
The first one is 21/4. At 2, kids, it says approaching 2. At where x is 2, don't we have a point? It's an open point, but it's still a point. And the limit at a point is the y coordinate, period. I don't care whether you're coming from the left or the right, it doesn't matter, it's the y coordinate. All right, what about the next one? Now, when you say 3, I want you to put a little plus up here, because you can actually approach 3, and that's what's happening. You're approaching 3, right? Your y guys are approaching 3, but you could be doing it this way too. We want to say we're coming in from the top. All right, what's the next one? 3 negative. You're coming in from the bottom over here, aren't you? And what about the last one? Negative infinity. Now, why is it negative infinity? There's an asymptote at -2. We're coming from the left side of -2. And as we come toward -2 from the left side, we are going down. There's no stopping that, right? You see the difference? This is coming down, but it's not going to infinity because it's being stopped, right? This one is going down forever. So that's a negative infinity. Okay? Now, all of the videos all of the review sheets are on video. So if you are studying over the weekend,